Okay. Yeah, hi, good morning and good evening. Welcome back. So yesterday, okay. So we started discussing VPC peering, right? So now we are entering into the real AWS concepts. So we are going to understand the concept as per the requirement, and then we will configure it through Terraform. Finally, we will make the RoboShop project in a secure and standard way. Okay. So now you are in a stage, you know about the Terraform general scripting concepts like conditions and then variables, data types, and functions, and what else? Loops. Okay, so you know these 5 basic concepts of programming, and on top of it, we have count and count index, and then outputs, data sources, locals. Okay, so these are the concepts we are using for the Terraform, right? So with these concepts, we will understand the service and then we can write the Terraform resources. Without understanding the service, it's not possible to write Terraform resource. Okay, you can write by seeing the documentation, but if you understand about the service, then it is really good. So you can write it effectively. So that is the same process for any cloud, any provider in Terraform. Okay, so actually we understood VPC and VPC peering. Okay, so now we will configure the RoboShop project into the as per the production level. Okay, so that is I'll make one more repository, RoboShop infra standard. Okay, so I'm creating, instead of changing the existing repository, I'm creating more repositories so that you will not confuse, and when you are practicing again from the scratch, so you'll have that copy present in our GitHub. So that's why I'm creating new projects, and again and again we are practicing so that we will get good confidence on the infrastructure part. Okay, so let us discuss a simple thing. So yesterday we discussed about VPN, right? So we will see that now. So this is the AWS account. And inside that we have the structure. Now I'm going to make this. So VPC is the ground for any project. Okay, whenever you are starting a new project, either in on-premise or cloud. Okay, it's not a AWS service, it's a general service. VPC is a general service, not AWS service. Okay, you need to create the VPC and then subnets, routes, firewalls, everything you need to create either in on-premise or cloud. Okay, that is the concept, not a patent to the AWS. Okay, so that is the main configuration, VPC. So this should be secured and it should have network security like subnets, something like that. So this is the VPC, and we have public subnet, private subnet. So this is public and we have private. So inside it will have internet gateways, route, and associations, everything is available. Okay. And so this is the public and private, and I'm going to create another VPC. So we have already a default VPC. This is default VPC. This is RoboShop VPC. So this is default VPC. So here we will have default public subnet. Okay, so let me take this default public subnet. So inside this, we will have one EC2 instance, that is VPN. We can consider it as VPN. We will install VPN software again, okay, after some time, but till now, we'll consider it as VPN. So this is VPN mission. And from here, we will connect. Oh. From here, we will connect to this VPC. Okay, not only public subnet, it is the VPC. Okay, so this is the thing we are going to achieve. As a user, you should always connect to VPN first, and from VPN you should get the access to the instances. You should not get the direct access. Okay, so this is the structure I'm going to do. So VPC is the ground for any project. So let us just once again recap. So what are we going to create the services? VPC, and then internet gateway and associate with VPC. And what else? We'll create, now we are creating public, private, and database subnets. Okay, high availability. So in 2AZ, we are creating public, private, and database route tables. Okay, and we are adding routes. NAT gateway. So NAT gateway as a route to private and DB subnets. When you can call a subnet as private is if you don't have any internet access. It means ingress internet access. Okay, you should not connect to the subnets from your servers. That is the ingress traffic. Okay, but the instances inside private and database subnets can originate the traffic. Okay, egress traffic is always through NAT gateway. Ingress is not allowed. If someone wants to meet us, they cannot. If we decide only, then we can meet them. So something like that. Okay, and then associations of route table and subnets. So this is just like a road. Okay, if you take a city, inside that a layout is a VPC. Inside that layout, you will have a lot of blocks, and you should have routes to connect. So that is the thing. So all the time you have to just visualize this process. Okay, whenever you are sending a request to the VPC. So now we got VPC peering. How we will do the VPC peering is, okay, we will take default VPC and we'll create EC2, and security group is allow all from your IP address, not from internet, from your IP address only. Okay, you can connect to this VPN. The security group is from your, this is from your home internet. Okay, nobody else can connect. So that's what I'm going to do now. And the instances here, they can only connect from the VPN, nothing else. Okay, so that is what we are going to do. So security group allow all from your your IP address. And then what about the routes, VPC peering? So here requester is default VPC. Okay, acceptor is RoboShop VPC. Okay, RoboShop should accept the connection, VPC peering connection. And after that, routes are very important. Generally, we miss to see the routes. If you just enable the VPC pairing, it is not enough. Okay, so you should always have a road between your VPC and their VPC. Okay, so add, for example, let us take default route table. So in this default route table, okay, you should have a road to RoboShop VPC. It means Destination is RoboShop CIDR. Okay. Road is peering connection. Similarly, other side, RoboShop route tables, all route tables. Okay. You should have road to default VPC. Again, it means destination is default VPC CIDR. Road is peering connection. Okay, so this is what we are going to do right now. Okay, so we have already the VPC module. I'm going to just do a simple change so that it can have the VPC peering connection also if customer wants it. Okay. So now I'm going to do, so another thing, another important thing, RoboShop is not a simple project. Okay. So just imagine as a big e-commerce real-time project. So you will have a VPN. This is a VPN Terraform. Okay. Entire VPC is going to be managed by one team. So that is, for example, networking team. So networking team is managing this VPC. So they are preparing the ground. Okay. In any project, the first work is done by the networking team to prepare the ground of VPC. Okay. And they have to store the parameters into SSM parameter store. Because that's a separate project. Terraform can get the variables within the same folder. It cannot get from the different folder. For example, we have multiple Terraform folders here. Okay. So this Terraform RoboShop infra user cannot go and get the variable values from this folder. Okay. Each folder is different. So remember this. Terraform has access to the current folder only. It can't go to another folders or projects. Another folder is nothing but another project and bring the values. Okay, so this is not possible. Generally, this is not possible, not at all possible. So that's why VPC project is created the ground, and another project VPN will start. Another team, VPN team will be there. Okay, so this project is storing the parameter store here, and while creating VPNs, he needs some values. This team needs some values, like what are the VPC ID, something. So actually, these guys will go and refer the values from parameter store. Okay. For example, these guys will refer from parameter store, and they will also store some outputs. So these guys also will store some outputs to the parameter store. And another project will start. So the VPC VPN is set up. Another project MongoDB will start. So all these things will start parallelly. Okay. So they will have contact between them. And these guys will also refer few values from here. And these guys will also store few values to the parameter store. So like this, the projects are going to be started, and then they will be storing. This is the centralized configuration. So this is where every project should store. Okay. So for that purpose, I can create projects like Terraform projects like VPN, VPC. I can create VPN, different repos. I can create MongoDB. Okay. But just for the simplicity purpose, I am creating in a single folder. Okay. But I will maintain here a numbering format so that you can understand at any point of time while practicing. For example, here I'm going to create VPC, and then I'm going to create VPN. with a number format so that you will understand, okay, this is the order of creation and you will not face any errors. Okay, so each folder is different. Each Terraform folder is different. Just consider it as a different project itself. Obviously, it's a different folder. Terraform is different here and here. Okay, so I will not know the full details of other team actually. So they will give me some documentation. Only I'm allowed to know those values. I don't know how those guys are working. That is just a simple, what can I say, a thin contract between the teams. Okay, for example, as a VPN team, I don't know what AMI they are using. It's completely their wish. We have catalog, for example. Catalog is connecting to the MongoDB. Okay, so as a catalog team, do you really care about what is the AMI they are using? What is the version they are using? Please respond in the chat. Is it necessary for you to understand what are the AMIs they are using? What is the OS they are using? No, obviously we don't need. What is the contract between us? We should be able to connect to the MongoDB instance. We don't care what is the AMI they are using, what is the OS version they are using. We don't really care. There is a thin contract between our two teams. So MongoDB should be responsible to make the DB up and running all the time, and they should accept the connections. So if we give the right username and password, they should store. Okay, they should insert. They should we should be able to read. We should be able to update. We should be able to delete. That is the contract between us. Okay, if there is some technical issue in that, then you can always question the team, but you don't have any rights to question their infrastructure. You don't have any rights to question their OS, their tools, their softwares, anything. Okay, it's completely their wish. Okay, it's a complete project management team, technical leader, architect. So many persons are there. So that is the contract. Okay, so that's what I'm going to reflect here. So this is the VPC team. VPC. So let us just have some provider. So first thing, you will create provider.tf, and I'll create main.tf, and I'll create variables.tf. Okay, and then let me copy some provider. Okay, here I'm going to just give it as VPC. Okay, and then let's create VPC. So source is always our Terraform AWS VPC advanced. Okay, I'll copy paste because we already know this and we already did this multiple times. So where is this VPC? Yeah, this is the one, right? So I'm copying this. So project name you should have, and in this approach, obviously you have to duplicate the variables. So here I need to create project name. Default equal to RoboShop. Okay, so let me copy those values also. CIDR, common tags, public subnet till here. Okay, so I'm copying common tags, public subnet, database subnet, CIDR. So CIDR is there, common tags is there, public subnet, private subnet, database subnet, CIDR is there. Okay, and variables is done. So now, as I said, we have to create parameters. Parameters.tf. So you know the syntax. AWS SSM parameter Terraform. Okay, so this is the resource. Now I'm going to store VPC ID. Okay, so what is the naming format? You can just say like this: var dot project name. Okay, slash, you can have just environment also. Just giving it as env default equal to dev. So we can have environment as var.env and then slash VPC ID. So this is going to be the our parameter store name. I mean parameter name. So anybody can see this belongs to the RoboShop project dev environment, and this is going to be the VPC ID. So what is the value here? You can directly write module.vpc.vpc ID, and module should have output declaration. So if you are calling this, then this VPC module should have the VPC ID inside its outputs. Okay, we have that already, right? So we have VPC ID. If you don't have here, obviously you'll get an error. Okay, let me remove this, comment it. Okay, so in a similar way, I'm going to store all the parameters here. Public subnet IDs. Public subnet IDs. Public subnet IDs. While doing this, just be careful. Copy paste mistakes will always occur. Private subnet IDs. Private subnet IDs, and then database subnet IDs and database subnet IDs. So we know this last time we got an error. So we need to convert into a string list, or let me just see what will happen. Okay. So this is the, yeah, that's all. So our module VPC module is ready, right? So you know that obviously it will happen everything. Okay. Provider variables, everything is fine. Now I'm going to do RoboShop infra standard. Okay. CD 01 VPC Terraform init. So one more reason why I'm doing this here is, if it is a big infrastructure, for example, let me go to our RoboShop infra user. So if I give Terraform plan here, it has to go through each and every TF files. So TF files are becoming more when the project is becoming big. If you make it in a, if you maintain it a single repo, every time it will take at least minimum 2 to 3 minutes to refresh itself. Okay, to refresh the complete infrastructure, it will take lot of time, and then it has to give you. So lot of read operations will going on in the background. So you can see it has to read everything, whatever you mention in the files. Then it will take a lot of time. Generally, if you once you create that, and if you want some change, again it has to read and refresh the complete resources. That will take a lot of time. But here I'm going to manage it into different projects so that the read operation will be very fast. Okay. So Terraform plan. CIDR block has not been declared. So we missed it. So now what should I do? I should create a variable definition here, CIDR. Let me create default equal to 10.0.0.0/16. So expected value came here. So we know the solution already. So where is it? Parameters. We need to just make it as string list and then join. This is the function we should use. Like this. Okay. So this is going to be string list. This is going to be string list. And this should be join. So while I'm doing this, please focus on if I'm doing some copy paste mistakes. Now, if I forget, then obviously there is a difference, right? You created the variable as private subnet IDs and then you are storing public subnet IDs. This is the major mistake we do while practice. Okay, you will think everything is good and Terraform also will not throw any error because there is no syntax. So while storing, you will store public subnet IDs in private subnet, then you will go mad. What went wrong? Okay, so while I'm doing this, you have to keep concentration. You have to keep your concentration and correct me. Okay. So let us apply it. Okay, let it run and we will prepare our VPC peering. So as a module developer, you are giving option whether they require VPC pairing. Okay. Is peering required? Okay. So default equal to false. So as a module developer, so you should give an option. If the user wants peering with some VPC, they should have the option. Okay. By default, I'm setting it false so that any single project, they can use this VPC module. And if they want pairing also, I can give them an option. Okay. So I'm giving is pairing required false generally, but here we will have the VPC pairing as well. Our module can do the VPC pairing also. VPC pairing with default VPC. Okay. So AWS VPC pairing Terraform. Okay. Let me take this. Just naming it as pairing and pair VPC owner ID. Will not keep this anyhow. This is the account ID, I think. The AWS account ID of the owner. Okay, I'm making it as not required. Okay, because our module can only support pairing with the default VPC in that current region. Okay. Peer VPC ID. What is this? Peer VPC ID. And then requester. So VPC ID is the requester. For example, this is the requester, right? So default VPC is our requester. So, okay, this is not the standard actually. This is as per our requirement. If the requirement changes to enable the pairing connection with the different account also, your module should be able to do. Okay. So default VPC is our requester. How can we get default VPC? So there is a data source to get the default VPC. Data source default VPC. Okay. I can just refer this. We'll get the default VPC data, entire data. what are the values available? You can just check here. So all the values are available. CIDR block and main route table ID. All the values are available here. So I'm just querying the default VPC data. So now I want the ID. So here you can just refer how you get the ID. So this ID, dot ID, if you give, you will get it. So now what I'm going to do here, data dot AWS VPC dot default dot ID. Okay, peer VPC ID, already we know, AWS underscore VPC dot main dot ID. Okay, auto accept is true. You don't need to go to the console and then again give the auto accept. Okay, so name VPC pairing between default and can just get var dot project name. Okay, so yeah, that's it. So this is good, right? And yeah, let me get it as merge of name and then var dot common tags. And yeah, that is good. So this will create the pairing connection. So let us try this. So now what are the values required here? Oh, sorry. So I did one mistake here. So I'm doing as a module development. So I should only ask for the variables. So this data source, I should write here. I should write here. Okay, data.tf. So I'm the module user. So module developer, they should only accept the values. Okay, var dot requester VPC ID. Okay, so this is the variable I'm going to declare. Okay, requester VPC ID, they should provide. Fine. So when is this VPC pairing connection? Just have count equal to var dot is pairing required question mark 1, otherwise 0. Okay, you got it. So we are going to create pairing connection whenever user wants it. Otherwise, we don't create. So that is the condition there, right? Yeah. So now it is our module user responsibility to send this. Here we will give as is pairing required equal to true. Okay, and then requester VPC ID equal to data.aws, like this we have to give. Okay, pairing configuration. Okay. Yeah, now this is good. Let us just go for plan. approve it. And then let us see. A pairing is created. So this is the requester, this is the acceptor. So now we need to add the routes as well. Okay. So what I can do here is I will cut this and then create a different file so that it is not confusing for us. Pairing.tf. Okay. So now we need to have the routes. So we discussed, right, the routes. Now this is very important. You should have a road to RoboShop VPC. It means the destination is RoboShop CIDR and road is peering connection. So now this is in the default route table. Okay. So I'm going to make it as, we know the syntax, AWS route Terraform. Just I'm naming it as public public default route means inside the default route table route. Okay, what is the route table ID? We need to give where dot this is where dot need to give default route table, right? So where dot default route table ID. So user has to supply what is the default route table ID, and then the destination. Destination is where dot CIDR block. Okay, so that is the destination. RoboShop CIDR destination, and peering connection. So that is AWS VPC peering connection dot peering dot ID. Okay, and then depends on it is the route table. So this is not required here because we are adding route to the public subnet inside, sorry, public route table in default VPC. So again, you need to make it as count. So this is a condition. If user wants, then only we will create. Otherwise, we don't create. Okay, so is this good? Now we need default route table ID from user. So create a variable default route table ID, and then we need to provide here default route table ID equal to data dot AWS VPC dot default dot main route table ID. Okay, that's it. Now let us apply directly and then check if any errors. So each time we cannot go for planning, that is killing at least 1 or 2 minutes time. Peering.tf second line number second. Is there a duplicate resource AWS VPC peering connection configuration in peering.tf line number 2 already declared in main.tf? I did not save this. Yeah, I did not save this. Now fine. Yeah, if you set the count, it means you are treating it as a list. Okay, here you can see you are treating it as a list. So this is like a list. And now it should be pairing of 0. Okay, even it is a single element, you should always give pairing of 0.id. Okay, since we set count parameter, I'll just write here. Since we set count parameter, it is treated as list. Even single element, you should write list syntax. Okay, of 0. So now the route is getting added. Let us go and then check. Go to the subnets of default VPC. Oh, sorry, route tables. Sorry. So I'm getting confused many times. Okay, so this is the default route table. Okay, and here you can check. So there is a route to the RoboShop VPC through peering connection. Okay, that's what we want. Similarly, we have to add the routes. Add route in RoboShop public route table. Okay, public. I'm giving it as available as route public. And there is one more thing here. We need to really understand this. I gave route here. So this is going to add one route in public. I'm adding again one more route here. Okay. So Terraform, while reading this route table config, so it will consider there should be only one route here. Why is it again adding one more route here? Okay. So anyhow, I'll show this now. Okay. We will understand how Terraform really works in the background. Public and route table ID should be AWS route table dot public dot ID. Okay. I'm adding inside this public route table, and destination should be what is the destination? Our default CIDR var dot default VPC CIDR. Okay, right? So how we will get? You have to create a variable default VPC CIDR, and our user should supply that. Okay, default VPC CIDR equal to data dot AWS VPC dot default dot CIDR block. So they have to supply, and yeah, this is the destination. VPC peering connection is same, and this is depends on AWS route table dot public. Obviously, it will take the dependency. No need to give this depends on. Okay, so now I'm adding the route, and it has already one route here. Now let us see what will happen. Terraform plan. Okay, let us apply. Okay, one is getting added. So you can go and check the route tables of RoboShop public, and you have the route to the default VPC. This is good. This is really good. So it is expected. Now if you just plan again, this is really bad actually. It is taking at least 1 minute. So now you can see, again, there is one change. What is it saying? I'm going to delete the route you added to the peering connection. Why is it deleting? Just understand this. Terraform is coming here. And you said, I need to add only one route into this public route table. And Terraform found another route. Yeah. So what it will treat, okay, someone else changed it. Someone else changed it in the console. Okay, but I need to match this configuration. So obviously, I will delete this. So that's what it is saying. Okay, so the best way is you should not add routes here. Okay, you should only create the route table, and routes should be always a separate one. Otherwise, Terraform will confuse. Okay, so here I'm going to add route separately. So now there is no chance Terraform will confuse. Okay, so what I'm doing here is public route table ID, public data ID, destination CIDR block is going to be 0.0.0.0/0, and then okay, here it's not VPC peering connection, it is gateway ID. Gateway ID equal to this one, AWS internet address. Okay, similarly, same applies for the security group also. Always add route separately. So similarly, our private route also, route in private table also. I'm going to comment this. I'm going to create private and then private, and this is NAT. That's NAT gateway ID dot main dot ID. Same for database also. Okay, so this is the way, and let us continue here. So public here I gave already as public. Where is this public? I need to give different name here. I can say public peering. So similarly, let me create private peering. Adding destination here, and then yeah, this is good. Similarly, database. Database peering, and it is going to add to database route table. Default VPC CIDR as destination through peering connection. Okay, so this is good. Now let us apply. So now let's go and check database route. Here you should have the destination to default VPC, similarly private. And now if you apply again, this will not give you any error. I mean, this will not change the infrastructure again. While doing some name changes, it seems really confused. Okay, what I do is, it is trying to destroy this one, public. Let me destroy this. Because I gave conflicted names, that is the problem. Interrupted. So now so I already recreated, right? So that is the problem actually. I should have commented first and then apply the changes and then again create the routes. So it is saying, you can see destination already exists. That is what it is saying. Okay, it's fine. Already exists error. It is okay. Let us proceed. Creating in route table 3db262. Let me delete so that it will not get the error again. 3db. So this is already exist. What I do is, now I will remove this one and another one 262. So this is already exist. So what I do, I will remove so that it will not get the error. The mistake I did here is, when it is exist, I just commented, I created the same resource again. So that is why it is trying to add this and it is finding the error. It's already exist. So when I comment this, I should apply once and then I should do the changes again. That is the right way. You know, Terraform is satisfied. So this is the whole VPC and then peering setup. So now this is done. Peering is done properly between our VPN and then our RoboShop VPC. Okay, so this is the network configuration. Now we need to start this VPN project and we need to have EC2 instance and then security group, those things. Okay, now I'm going to create VPN project here. Let me copy the provider. and then here I'll just name it as VPN as usual, main.tf, and then variables.tf, and then data.tf, parameters.tf. Okay, first thing, I need EC2 instance and security group. So EC2 instance always depends on security group. First, I need to create security group. Module VPN security group. Okay, we have the module already available. Source equal to our Terraform AWS security group, and then let me copy that syntax. It is in Photoshop infra user. Okay, so this is the syntax we need. I'm just copying it and then keeping it here. Okay, this is the project name, and then so you are declaring variable here. This is a different project, so obviously you should have project name here. Okay, default equal to RoboShop. Treat it as completely different project. Okay, and SG name. What can we keep it? RoboShop VPN. Okay, so allowing all ports from my home IP address. I'm not going to give the internet access full. So ingress rules, as I said, you don't give ingress rules here. Create ingress rules always separately, and then VPC ID. Here it's not local. What I have to do, I have to refer from the parameter store, but this is going to be default one, right? So I need to fetch the default VPC. So again, get the default VPC data source, and then here you need to give data.default.id. So I'm creating this in default VPC. Just check this. This is default VPC. I need to give default VPC ID, and the common tags you can give. Okay. So that's it. Now it should create, and I need to create rules also. Resource or AWS security group rule Terraform. So this is going to be VPN ingress from and to 0, and then protocol TCP, or let us give the full 0 to 65,535. Okay, this good. And TCP. Now CIDR block is usually I give here 0.0.0, so that will accept the connections from internet, but I don't want to give it from internet. Okay, let us just work on this. AWS security group. Okay, sorry, it is module.vpn.sg.security group ID. Okay, so this security group, I'm going to add a rule to allow all ports, but from which CIDR block? This is from my IP. Okay, you can just type, how can I get my IP address in Terraform? Okay, so what are they saying here is, so just have a data source. Okay, then this URL will get the IP address. Okay, Terraform can use this URL and it will fetch the IP address. This is like HTTP request. Okay. And then in the rule, you have to add like this. Okay. So in rule, you have to add like this. Now let us check. Oh, this should be in different projects, right? Sorry. 02 VPN Terraform init. So this is how you should really build the infrastructure in real time. Okay. So all teams work together. Terraform apply auto approve. Common tags is not declared. Let us just give copy it from the previous. Okay, so here I'll add one more thing. For example, component. Component equal to, this is VPC component. Okay, it means like VPC project. So now this team belongs to RoboShop. This is the RoboShop account and this is the VPC project. So similarly, let us have common tags. So this is the RoboShop project, but this component is VPN. This is VPN team. And we can give environment, right? Environment default equal to dev. Okay. Right, now we apply again. So it is getting the IP address from the data source and it is adding. Okay, now if you go and then check the security groups, we see RoboShop VPN. That is our security group. Oh, it is here. Okay. RoboShop VPN. Can just see here. Can just see the inbound rules. So traffic is only allowed from my IP address. Okay, so this is my IP address. Nobody traffic is allowed. So now let us create instance. Okay, module VPN instance. Okay, we know that already we used EC2 instance, right? Let me take this. This is VPN instance. Okay, this is the source. This is the AMID. AMID, we need to get the data source. So copy the data source. Data source is done. And what else? T2.micro, you can keep it. And VPC security group IDs. So what is the security group you need to give? You need to give the above one. Module dot VPN dot SG dot security group ID. Okay. And then subnet. Subnet, this is going to be in public subnet of default VPC. Okay. So that is what we are doing here. You can see this is going to be default public subnet of default VPC. How can we get that? Let us go and then check. Go to subnets. And let us check with this. This is the default VPC. And let us search. So it has 6. And then in each availability zone, it has one subnet. Okay, you can see this. How can I get into this? So I need to fetch the data source. That's for sure. Generally, so we have an option here. EC2 instance Terraform. So there is a subnet ID. Subnet ID. Okay, this is optional. If you don't give, what will happen? This will go and so this is optional. If we don't give, this will be provisioned inside default subnet of default VPC. Okay. That's what we are doing, right? Whenever you are launching the instance in the console, obviously it will select the default VPC and default subnet. So this is optional. You don't need to worry about this. Okay, user data we don't have for now. And name is going to be RoboShop VPN. Okay, we can have common tags. So we have common tags. That's it. Okay. Yeah. So it is saying install Terraform init. So whenever I'm doing, just visualize this diagram. Okay, what I'm doing here, just visualize this. Now Terraform apply approve. Okay, it is creating the instance. Now you can check the security group. So earlier we are using allow all. So some of you also generally we gave an option to hack others systems if you know the IP address. Now there is no chance you can connect. Now you can see only I can only able to connect. If you try to connect, so this will definitely timed out. You are not allowed to connect. Only I am able to connect to this VPN. Okay. Now let us try to connect. Okay. So now obviously you guys cannot connect. Okay. While you are doing practicing, for example, if two persons, like one person is helping another person, if the other person wants to log in, so now that guy, whoever wants help, you should go and then add a security group rule here to allow other person IP address. Okay. Just understand this. Person one wants help. Okay. But his VPC, his security group, not allowing others. Now, person two is the helper. Person two is ready to help. So what this person one should do? Can someone type in the chat? What this person one should do? Person one should add IP address of person two to his VPN. Okay. So VPN is completed. So the next thing is MongoDB. Okay, MongoDB. Let me create another project of MongoDB, and here same provider, just name it as MongoDB. Okay, let me initialize first so that we can save some time. CD MongoDB. And let me name it as 03. Terraform init. Okay, here again main.tf and then variables.tf, data.tf. Now I need to export some parameters also. Here you can see I need to export some parameters so that MongoDB can use it. Okay, we are going to see that now. Anyhow, so in MongoDB, first thing is to create security group. MongoDB SG. Okay, so I'll copy the syntax here. So this is the syntax, right? Project name, I need to have the variables. Let me copy that variables also. This component is MongoDB. Okay. This is the project name, and here we can say VPN name as MongoDB. So now allowing traffic, and then VPC ID. So this VPC ID should be obviously our RoboShop, right? So how can we get the VPC ID? So we need to have a data source. Okay. So this VPC stored the VPC ID here. I need to refer. Okay. SSM parameter data store, data source. So I'm querying AWS data source. I'm just naming it as VPC ID. What is the name of it? So the name of it is this one. This is the name. So now here the name is this one. Now AWS, when you write a data source like this, it will approach SSM parameter store on this value. It will search this value. Okay, let us go and then search parameter store. Okay, we have this RoboShop dev VPC ID. Okay, it will go and fetch this value. Okay, so we should have environment also as variable. Yeah, we have variable. And now it is data dot AWS SSM parameter dot VPCID dot value. Okay, and then common tags. So this is the security group, and this is the data source provider variables. Okay. Now Terraform init again to install the module. Now Terraform apply. Now this will create security group for MongoDB. Yeah, we got it. RoboShop MongoDB. Just go and then it is created. Now we need to add the inbound rules. So what is the first inbound rule we should add? Okay, what is the first inbound rule we should add? And someone please type in the chat. MongoDB VPN. So we should allow VPN traffic, right? So that users can do on port number 22. We don't need to give other ports, because if something goes wrong, so they will get the 22 port number 22 access, and then they can check what went wrong. Okay. Here CIDR block is, this will not work as CIDR block. Okay, this is a crucial concept. Now let us understand this. Okay, I'm adding a rule SSH port number 22. It's a custom, and then you can just see let me go to EC2 instance. So now this VPN instance has one security group. Okay, this one. Why is it not displayed? Yeah, this one, right? 63F. Now this one should be there. So again, let me refresh. This is MongoDB security rules, and I'm adding a rule. I want port number 22 to be allowed from SG this one. Yeah, this one actually. So what I mean to say here is, so focus on here. So it's very important. So this is MongoDB. This is MongoDB EC2, and this is like VPN EC2. Okay, so if I add security group ID of this EC2 in this here instead of CIDR block, so you have two options: either add CIDR or add security group attached to EC2 instance. Okay, what is the meaning of this? So IP address may be changed at any point of time, but if you add the security group attached to the VPN instance as the source here instead of CIDR block, it means we are allowing the traffic from this instance. Okay. Yeah, this is little bit maybe tough to understand for the first time. So you have two options. If you just check the documentation, AWS security group rule, Terraform. So you have an option called source security group. Source security group ID. It means the traffic, where is it originating? Okay, so we have VPN. VPN is connecting to MongoDB. What is the source and what is the destination? What is source? Type in the chat. Sri Lakshmi Reddy, type in the chat. What is the source here? VPN. What is the destination here? MongoDB. Right? So now in MongoDB SG, in MongoDB security group, if I add the security group of VPN, then what does it mean? I am allowing traffic only from the instance connected with this one. Okay, understand again. Source is VPN. From VPN, we are connecting to MongoDB. So in MongoDB security group, generally you need to add the IP address of this VPN. Instead of adding IP address, I am adding the security group of VPN instance. So now what I'm telling, so if you get the traffic from VPN instance, allow that. That's all. Okay, so you can see the documentation of security group ID is allowed to access to and from depending on the type, cannot be specified with CIDR blocks. You have to either provide CIDR block or you have to provide either source security group ID. So now CIDR block, I don't want to provide because that may change anytime. Okay, when you create stop and start the instance, the IP address may change. Instead of that, if I create the source security group ID, then obviously whatever the instances connected with this source, I'm allowing. For example, for a high availability, so generally what we do, we have two VPNs. Okay, Let's understand this. Two VPNs, VPN SG. Now in MongoDB, I have VPN SG as SG rule. Now what does it mean? So I am allowing connections from these two VPN servers, right? So that's it. This is the very important thing while writing the security groups. Now I don't want this CIDR. I want to create source security group ID. So what is the source? Obviously it is VPN security group ID. Now I need to export here. Export the parameter. VPN SG ID. Okay. What is the value? This is module dot VPN SG dot security group ID. I need to refer this in the data source. Okay. So VPN team exported the parameter VPN security group ID so that other teams can use it. Now MongoDB team wants to query this parameter store and they can use it. Okay. So now MongoDB in their security group rule, so they will give data dot SSM parameter. I need to give VPN security group ID. Okay. So while exporting this guy, VPN team, they have to export the value VPN SG ID. Okay. So as a MongoDB team, you need to refer that value VPN SG ID. So now here VPN SG ID dot value. Okay. Now what is this? MongoDB SG dot ID. So now you are adding a rule to the MongoDB security group that is allowing the traffic from VPN instance. That's it. Okay. Now let us apply this. So once you understand this, then this will be good. For all the things, we are going to do the same. So there is some error in main.tf. It is at the 19th line. What is the error here? It should be security group ID. It is saying parameter not found. Obviously, I didn't export it from VPN team. So I'm applying. This will create the parameter. Okay, that is done. And then let's go to this MongoDB and apply. And now you see here. So MongoDB is allowing connections from VPN. So now tomorrow I'm getting a lot of traffic. I'll create another VPN instance, for example, another VPN instance, VPN 2. Okay, our employees are increased. I'm going to select VPN 2. Now here the security group, what should I select? So this one, I'll select this VPN security group I already created. Now, obviously, our MongoDB will allow the connection again from this VPN2 also. Okay, so final statement, MongoDB allow connections from the instances that have sorry, what is that? Let me go to the security group. So that this one. Okay. SG group as this one. Okay, you can create 10 instances, but if that instance have this security group, then MongoDB will allow the connection. Okay, so that is the final statement. Now let me create one MongoDB instance and then we can leave for the day. So now I will create one MongoDB instance. Okay. So anyone have confusions? Okay, we will repeat again, don't worry. So this is very important point you should understand. Okay. So this is MongoDB instance. Where I need to provision this? Can someone please type in the chat? Where I need to provision this instance? This is t3.medium and then security group ID. It is obviously module.mongodb sg dot security group ID. Okay, so where should I provision this generally? Where should I provision? Please type in the chat. It should be in RoboShop DB subnet, right? So how can I get DB subnet? I need to write a data parameter stored database subnet IDs. Okay. I need to get this database subnet IDs, right? And how can I get it? We can just refer RoboShop infra user and then EC2. Is this locals? So usually IDs of 0 I will give. Okay, so the same way here. So what I'm going to give here is data dot SSM parameter dot database subnet IDs of 0. Okay, so this is going to be MongoDB. Okay. Yeah, right. And now security group is MongoDB security group is created and we provision in database subnet ID, right? So now let us go for Terraform plan. So Terraform init we should do because I added the module. In Terraform plan, just while writing the resources, understand where you are creating. So AMI is not declared, and what else? Subnet IDs of 0 dot value. I should give as dot value, and then this data source I need to give dot value of 0. So it has 2. The dot value will get 2 and it will get the first one. Just let us check here. Parameter store. So you have comma separated. I'll get the first one. Okay. So now Terraform plan. Okay, so now let us understand how to get first element from SSM parameter string list. String list Terraform. So from the string list, I need to split it generally. Split based on split and get first element Terraform. Okay, so that is let me write it. Split of I'm splitting using comma data dot SSM parameter subnet IDs dot value. Okay, and this is going to be element of this will give the list and dot 0. Okay, first I'm splitting it, splitting based on the comma. So out of this, I'm selecting the 0 value. I mean 0th index. Let me check the luck. Okay, it is good. We are able to get the subnet ID. Okay, let us apply. So this parameter store, actually AWS, I hope this did a mistake by inventing new data types. I don't know what is the reason. Let's go to the instances. Okay, we are getting MongoDB, and then you check it. It should be in the RoboShop database US East 1 here. Now, if you check the security group, it is allowing connections from VPN. Now, this is fine, right? So if something goes wrong, what you usually do, you log into VPN first. Okay, I already logged in, and then I will go to this one. Okay, as such, CentOS @ private IP. Okay, it is just started, right? Let us wait for it. DevOps 3 to 1. Okay, now I am inside MongoDB instance. Okay, I connected to the VPN and I connected from there to MongoDB instance. Okay, yeah. So can I spend 5 more minutes and then install the MongoDB here, so that at least it will be somewhat completed, and you can practice it in next 3 days. Okay. User data, I'm going to give file of mongodb.sh. Okay, I'll write one script, mongodb.sh. So what this will do is this will have bin bash. Okay, so we have our shell script already, RoboShop shell script. Okay, what I'm going to do here, I will clone this. I will move to temp directory and I will clone. Okay, I will go to this directory here, and then I'll write sh, I'll run sh mongodb.sh. Where is this mongodb.sh? mongodb.sh. Okay, so now I will terminate the instance. On Monday, we will see something called provisioners, because this user data, now I created the instance already. Now, if I give user data, there will be no effect. Okay, only for the first time it will run, first time creating the instance. Otherwise, it will not run again and again. Okay, so if you want, you can keep this in locals. Okay, if you feel that it is not in a readable format, and I can give locals and db subnet ID. So how I got this idea? So how you get this idea generally? If you see this, so this one, I want this first value. So obviously I need to split. How you split? Based on comma. When you split it based on anything, you will get these two into a list. And out of that list, I want the first one. Okay. First one always refers 0th index. Now you can get local.db subnet ID. Okay, instance is deleted. Now if we apply again, you guys can connect to my MongoDB through any way. Is there any way to connect to my MongoDB instance? You guys just answer it. No. Nobody can connect except me. It's a such. These are the minimum security measures mostly every project ignores. Okay, simply for the fastness, or maybe they are in hurry, they are not aware of security groups properly, so they will go and enable lot of rules have that may allow others like hackers to connect to the systems. Security group is a very simple concept but very powerful. Earlier, this instance provisioning was very fast. Nowadays, it is taking some time, maybe because the servers are in North Virginia. That is the problem, or the provisioning should be always fast. Okay, now you just check the output. Cloud init. Okay, so copied MongoDB typo into m.repos.t. It is installing in the background. So now, as per our architecture, who else can connect to the MongoDB? Who else can connect to MongoDB? Can someone type in the chat? Who else should connect? Catalog component and then user component, right? So I just enabled some colors here. Catalog is blue color, user is this black color, and this cart is red, this is green, this is pink. Okay, black user, blue catalog. So now I should enable security group rules. So these components, the security groups attached to catalog, security group attached to the user, I should allow that. Okay. Since these instances are not yet created, so we will do that later. This comes under operation. So now there will be a separate operations or support team. So they will be changing the security group rules based on the flexibility. So our responsibility is to create the infra, but there will be always some operations going on, operations and support. Okay. Yeah, it is done. Now you can check netstat-lntp. Okay, this is done. So in our next class, we will provision catalog instance through the auto scaling group, load balancers, launch templates, and then target groups. Many AWS concepts we will discuss, and then we will connect to the MongoDB. Okay, so that's all for today. Any questions? Satta?
Yeah, hi, Siva. Good morning.
Yeah, hi, good morning.
You are writing this script in YAML format, right?
Where?
This Terraform script.
Terraform is YAML. Do you think it is YAML?
Sorry for the confusion.
No, this is not YAML. This is HCL, HashiCorp configuration language.
Okay.
Okay.
A small confusion between playbooks and this script. Playbooks we are writing in YAML format, right?
Yeah, correct.
Okay. My doubt is simple. Like, why are you spending this much time on Terraform, like instead of Kubernetes?
Why should I spend Kubernetes? Kubernetes is the next level concept. First, you should understand the AWS resources, right?
Okay.
Without understanding AWS resource, how can you create EKS? Without VPC, without subnets, without security groups, how can you create VPC? Without roles, without load balancers? Are you aware of all these things?
No, no, I have done this. I heard, but
Maybe you are working in a company where you have the Kubernetes cluster already provisioned. You just
yeah.
simply give kubectl get nodes, kubectl apply -f manifest file, because someone created the infrastructure and everything already. So you are using it. Now we are creating the infrastructure so that others can use.
Okay.
Okay. So we are working on Terraform infrastructure so that we are preparing the ground for applications. So you are deploying applications in Kubernetes cluster without having VPC, without having subnets, without having IAM roles, load balancers, and EKS. You cannot deploy the applications.
Okay, thanks.
Okay. Srinu?
Yeah, hi Shiva, good morning.
Yeah, hi, good morning.
Yeah, actually, what is the difference between this VPN and jump server?
Jump server is like a bastion host. Now this is a jump server. Okay, even I'm calling it as VPN. This is a jump server. Jump server is nothing but you are jumping
Yeah,
from one place to another place. I'm
yes.
jumping from VPN to MongoDB. So this is the jump server. I'm taking this as an advantage,
Okay.
right? So
The purpose
actually,
of both are same, right?
yeah, both are same. Actually, instead of connecting here, I can install one Open VPN. There is one component called Open VPN. You know Cisco VPN, all of us, we use that, right? So this
Yes.
Open VPN, if you install and just click connect, then I will show that anyhow. Okay, wait for
Right.
it.
And one more thing, this VPC and all things for dedicated network team will be there. No, we wanted to do it, right? Or
See,
network team will take care.
when it is cloud, you should be aware. So maybe they created while you are deploying applications, you should know where you have to provision your applications. So they will not come and then they will not tell you, they will not help you to provision this in this subnet, to provision in that subnet. They will not help you.
Okay,
Okay.
got it, sure. Thank you.
Yeah, that is based on the project. Now, if everything is in cloud, they expect you should know everything.
Okay.
Yeah. So if it is on-premise, obviously dedicated networking team will be there because we need to maintain our data center. We need to lay the cables. We need to manage the subnets, cooling system, physical security, everything. But when it is coming to the cloud, everything is gone. There is no dedicated network team also sometimes. You have to manage your own VPC.
Yes, got it. Thank you.
Yeah. So any other questions? Is today's concept clear? You have to obviously watch it again and again and then focus on it. Okay. So the same thing we will apply for every component. So at the time it will become more easy for you. So yes, Janardhan.
Yeah, hi Shiva, good morning. So
Yeah.
in the security group, we have selected the source as security group, right? So in one of the
Yes.
The main reason is like instead of selecting the individual instances, so we are selecting the security group so that whichever the instances are attached to that security group will be allowed as part of that particular rule. That is
Correct.
right?
Yes.
So that is one of the kind of filter that we are using for selecting multiple instances.
Yeah, correct.
Okay. Thank you, Shiva.
Okay. So there will be a security loophole. I can give the CIDR block of entire default VPC. Okay.
Hmm.
So in that case, whatever the instance created inside the default VPC, I'm allowing for everything. Right. Instead of that, I'm just going to the very low level so that nobody can get access except that VPN server.
Yeah, correct. So yeah, that's correct. Shiva. Understand. Yeah.
So that's all. Have a nice weekend. Practice well, and we will proceed with other components in the same process. Okay.
Okay.
Have a nice weekend. Bye bye. See you on Monday.